So looking at number 9 here, we're going to be working with some more sums. So it doesn't say sum or it doesn't say S here, but remember we know the sigma means sum. So eventually we're going to be using this S sub n equals n over 2 times a sub 1 plus a sub n. And that formula is on your formula sheet under arithmetic for the sum. Okay, couple things here. First off, this a sub 1, even though it says a sub 1, it just means first term. So this is a little tricky because you're starting at 30. So this really means you want to get a sub 30 here. Okay, so to get our first term, you're just going to plug in whatever number's at the bottom. Doesn't matter what it is. So to get a sub 30, if you plug in 30 there, you'll get negative 118. So this number here is going to be negative 118. And then a sub n really doesn't matter what your n value is. This just means your last term. So to get the last term, you would plug in the top number here because that's going to be the last thing. So we would need a sub 100, which will give us negative 398. Okay, so first term, last term really doesn't matter what these numbers are, so don't think it always has to be a sub technically 1, it's just that's the first term. Okay, to get your n value is tricky here. So I want to do a little side examples before we do that. So if I had a series that started at 0 and went up to 3, and you were just going to plug it into some formula. If you're going to do this by hand, you would plug in 0 first, then you would plug in 1, then you would plug in 2, then you would plug in 3. So technically you had 4 different numbers here, so the case would be n equals 4. Okay. So another example before I tell you how we're going to relate this. Let's say we're going from 10 to 12. Plugging into something. You would plug in 10 first, 11, then you would plug in 12. So there's really 3 numbers here. So a lot of times when people try to get the n value, so like for this 3 and 0, they'll do 3 minus 0, but that's 3. And that's not going to be the right n value. So you have to add 1 to that if you're going to take that technique. So like here, so that would give you the 4. So here you'd have to do 12 minus 10, which is 2, but you'd have to add 1 to get that 3. So when we're trying to get our n value for number 9, we can do 100 minus 30, which is 70, but we're going to have to add 1 to that to get 71. So 71 is really the n value that we need to use there. So if you calculate that, you should get negative 18,318 for our sum. So for number 9, that should be your sum that you end up with. Okay, and because they gave it to you in this form, you could, if you had your calculator, you could go to Math 0 like we did yesterday, and that would, you could type in just to make sure that you're correct. Alright, taking a look at number 10. So number 10, they just give you the list of numbers, but because they have the additions here, we know we're trying to find the sum. So we're going to be using our S sub n equals n over 2 times a sub 1 plus a sub n. So let's fill in what we know. We know a sub 1 means the first term. Well, they give us the first term is 50. So we can go ahead and fill that in. So this is the first term. We know that a sub n just means the last term. Well, they actually gave us the last term here, and that's 107. Okay, so we're really just missing n this time. So if you wanted to write out this pattern, you could always do that to figure out how many terms there are. Or remember, we can always go back to our explicit formula and see if we can get that to help us. So we're trying to figure out what n is. We know a sub n is 107. We know the first term is 50. We don't know what n is. And we don't know what the common difference is, but we can figure it out. So from here to here, they're adding 3, adding 3, adding 3. So the common difference is positive 3. So we have 107 equals 50 plus 3n minus 3. So if we combine our terms, and so we'll have, if we can subtract over, we'll have 60 equals 3n. So n is going to give us 20. Okay, so n is going to be 20 here. So if we calculate this, our sum will end up being 1,570. So that'll give you your sum there. Alright, our last problem, and we're going to be looking at a word problem. So guys, I've actually left off day 5 in this unit, and day 5 was just all word problems. So pay attention to the word problems that I give you because they're the most important ones that you really need to know. So looking at 11, determine the total compensation from a company through 8 full years of employment if the starting salary is $40,500 and the annual raise is $1,200. Okay, so we're gonna look at each part of this and see what does it mean. So total compensation. This means that this is the total amount of money they've made over that time. So that means we're going to need to add all their years together. So we're going to need to find the sum. So eventually we will be using our sum formula. So it looks like that. Okay, 8 full years. So 8 full years. That is going to be our n value. So n is going to be 8 full years. Then it says the start is 40,500. Well, start is your first term or your initial salary, so your A sub 1 is the 40,500. And then each year you get a raise, so they add 1,200 to your previous year. So the common difference is going to be that positive 1,200. Okay. So filling this in, what we have. We know that we're doing S sub 8. We know N is 8 because they worked 8 full years. We know the starting salary, A sub 1, is 40,500. But right now we don't know what they made on the 8th year. So we're going to have to use our explicit formula. We're looking for A sub 8. We know the first year they made 40,500. Working for 8 years, and the common difference is 1,200. So if you were to add those together, you will get 48,900. So on the 8th year, that person's making 48,900. Okay, but we want to sum all these together to get their total compensation. So if you just sum that stuff and add that and multiply by 4, you should get $357,600. So after 8 years, that's the total amount of money they made over the whole 8 years.